Today we are going to look at how to solve exponential equations. So these are equations where you have x's in the exponents. And now that we know something about logarithms, we are going to be able to do this. Although the first type, you really don't need to know much about logarithms to do the first type. The first type is exponents on both sides. So in your notes, you might want to jot down right here that this is exponents on both sides. We're going to do exponents on both sides, exponents on one side, and then the next video we'll do logs on both sides, logs on one side. Okay, if you have exponents on both sides, we're going to be using this property. If you've got something raised to the x equals something raised to the y, if those bases are the same, then the exponents have to be the same. So take a look at number 1. 5 to the stuff equals 5 to the other stuff. The 5s are completely identical. If the 5s are identical, then this part also has to be identical because of this thing called an equal sign. That equal sign says that the two sides are exactly the same. So if the 5s are exactly the same, then that green part is going to be exactly the same. So this is actually a super easy problem. 3x minus 2 equals 5x plus 8. We've been solving this type of equation for years now. Get your x's all on the same side. I like to keep mine positive, so I'd subtract 8 on both sides, divide by 2, and I get x equals negative 5. Number 2, there's actually a typo here. This should say e to the 3x equals e to the 2x minus 1. That minus 1 is supposed to be up in the exponent. That's definitely a typo on my part. I'm sorry. So notice e and e are the same. So what has to be true about 3x and 2x minus 1? So pause the video, finish solving this. Okay, easy peasy. So then we get to number 3. And I notice that 8 and 2 are not the same. So we need to think about the smaller number 2. Can we rewrite 8 using that smaller number? So take your bigger number and rewrite it using 2. 8 is the same as 2 to the third. 2 to the third equals 8. So we are going to take this 8 out and put 2 to the third in its place. The x that was there is still going to stay in the exponent. Okay, I'm going to do this one more time using some different colors to help you see this again. Okay, so the 8 and the 2 are not the same. So the 8 is going to leave the equation and be replaced with 2 to the third. 2 to the third is the same as 8. So we're just taking the 8 out and putting 2 to the third in its place. The x that was originally in the exponent is still in the exponent. And the other side, we haven't changed at all. You can't make the smaller number bigger. You're going to take the bigger number and rewrite it using the smaller number. Now we've taken this and we've rewritten it in a way so that 2 and 2 are the same. So now we can do 3x equals 5x plus 2. Okay. We can subtract 5x on both sides. Okay. Let's try another problem like that. 27 to the 2x equals 3 to the 5. 27 and 3 are not the same. So you want to take the 27 and think about, could I rewrite 27 using a 3? 3 squared is 9. 3 to the third is 27. So the 27 is going to leave this equation, and we're going to put 3 to the third in place of the 27. That exponent of 2x is still there, and this is going to equal 3 to the 5th. Now the one thing that you need to remember, because you might see these not very often, but say that this exponent had been like 2x plus 3. So if it had been like 27 raised to the 2x plus 3 equals 3 to the 5th, then when you change that 27 into 3 to the third, you would need to put that 2x plus 3 in parentheses. So you're multiplying your new part of the exponent with the old part of the exponent, and that may involve using parentheses. Okay, but going back to the actual problem that we now have 3 times 2x, which is 6x, equals 5. The 3's are now the same, so this and this are the same. So that means that x equals 5/6.
Mama.
Okay, now sometimes we don't have exponents on both sides. Sometimes we only have exponents on one side. And I want you to focus on what this gray box says. When it is not convenient to write each side of an exponential equation using the same base, you can solve it by changing the equation to logarithmic form. We're going to ignore what these directions say. It says taking the log of each side. We are going to focus on changing the equation to logarithmic form. So I want you to remember, if you have b to the x equals y, if you have exponents, that's exponential form. To change it to log form, we have to do the log ride. Woo! That's log base b of y equals x. Okay, so that log ride helps you to know what order to write those things when you change it into log form. Do you remember that from when we first started doing logs? Now the key here is you have to make sure that you isolate the exponent first. So wherever the exponent is, you have to get that exponent by itself first. So in number 5, 2 to the x equals 7. 2 to the x, that's where the exponent is. It's completely by itself. So we are going to switch forms. We're going to take the log ride. Woo! Rewrite that as log base 2 of 7 equals x. Now, if you have a TI-84 calculator, you can do alpha window 5 to evaluate log base 2 of 7. Alpha window 5, you can type in log base 2 of 7 and get a decimal. So this answer is 2.807. They usually want you to round it to 3 places after the decimal. What if you don't have this fancy calculator? You can use change of base. Remember to evaluate log base 2 of 7. You do log button 7 divided by log button 2. The important thing is that you close your parentheses before you do the second log. And you get the same thing. Now let's look at number 6. Number 6, the thing that has the exponent is the e. It's not 4e to the 3x, it's 4 times e to the 3x. So we need to get that e to the 3x by itself. And we do that by dividing both sides by 4. Now the thing that has the exponent is by itself, so now we can change forms. Woo! Log base e of 3 equals 3x. Now if you go to evaluate log base e of 3, you might have some trouble because how do you put that e in the base? How do you get just e without an exponent? But you need to remember, and you might want to write this off to the side, that log base e of something, let's use n, is the same as ln of that thing. Log base e is the same as ln. So this is ln of 3 equals 3x. This is even easier. We can just type in ln 3. We get 1.099 equals 3x. Divide both sides by 3. Oops, 1.099 divided by 3. Our x equals 0.366. Now, if you didn't round it right there, if you just left that in your calculator and then said divided by 3, you would still get 0.366. So it doesn't really matter if you leave that in your calculator or if you use the rounded form when you divide. Okay, we're going to ignore number 7 for right now and go to number 8. Number 8, excuse me, we need to get the thing that is raised to the exponent by itself. So the first thing that we need to do is subtract 7 on both sides. So 5 to the x equals 26 minus 7 is 19. Now we're stuck. Anytime you're stuck, do the log ride. Woo! We have log base 5 of 19 equals x. We need to evaluate log base 5 of 19. You can either use alpha window 5 if you have that kind of calculator, or log button 19 divided by log button 5. If your calculator puts parentheses in, you just have to make sure you close those parentheses before you continue. So I'm going to do it that way. Log 19 divided by log 5. 1.829 equals x. Okay, you are not going to see problems like number 7 very often, but I do want to show you how you can use this same method for doing this. So I'm going to kind of box this out so I have some room here. 2 and 5 are not related. You can't rewrite 5 as 2 squared or 2 to the third or anything like that like we did before. So we're kind of stuck. You can still take the log of both sides. So 2, or you can rewrite this as a logarithm. The 2 is by itself with that exponent. So I am going to do the log right. And honestly, this 7 kind of is confusing right there. So I'm just going to cross that out. Woo! Okay, log base 2 of 5 to the 2x equals 3x minus 7. Now, do you remember when we expanded and condensed? If you've got something in an exponent inside a log, that thing is going to move out in front. So this is 2x times the log base 2 of 5 equals 3x minus 7. We can evaluate what log base 2 of 5 is. Oops, I did that wrong. Log of 5 divided by log of 2. So we have 2x times 2.322 equals 3x minus 7. You can multiply that 2 with that decimal. 4.644x equals 3x minus 7. I know this decimal looks gross, but you can do this math. Oops, 1.644x equals negative 7. Divide both sides by 1.644. Negative 7 divided by 1.644. My answer is x equals negative 4.258. Okay, now I did not give you one of those in your assignment. Your assignment is more like the other problems. So if you're looking at this and saying, whoa, Mrs. Gilmore, like, whoa, that's totally fine. Focus on numbers 1 through 6 and 8 because those are much more like your assignment. Your assignment today is on Big Ideas Math. It's called 6.6 Part 1.